Welcome everyone to this site event panel debate about Arctic monitoring, understanding current and future challenges through examining the past. I am Professor Anders Schumacher from the Department of Geosciences at UiT, the Arctic University of Norway. And the topic of this Mohn Prize panel is reflecting the field of study of John Small, the winner of the Mohn Award. And Professor Small is renowned for studies on historical variations in Arctic climate and environment, which contributes to our understanding of the current and future challenges related to climate change in the Arctic and also beyond. And through multidisciplinary and innovative assessment methods, the Mohn Prize awardee has underscored the importance of knowledge of the past to better equip ourselves for the future, and also that time matters. So we have an introduction before the panel debate, and I'm actually waiting for the last panelist, but I will just briefly introduce the panel before I give the word to Professor Small for the introduction. So first I would like to invite Marie Bulinova up to the scene here. Marie Bulinova is a PhD candidate at UiT, the Arctic University of Norway, Department of Geosciences. And Marie's PhD project aims at improving our comprehension of methane-related processes in lacustrine sediments, lake sediments in Svalbard and northern Norway and elsewhere in the Arctic. I would also like to invite up here Professor Niels Christian Stenseth from the University of Oslo. And Professor Stenseth is a curiosity-driven scientist combining theoretical and empirical approaches to study ecological and evolutionary processes. Then I would like to also invite the last panelist, Associate Professor Camilla Bratland. Please join us up here at the podium. Camilla is an indigenous coastal Sami person from northern Norway and also associate professor in Sami cultural studies at UiT, the Norwegian Arctic University Museum. The University Museum is part of UiT, the Arctic University of Norway. And then I would also like to invite John Small, the Mohn Prize laureate, up here to the podium. You will both join the panel. Join the panel, and you will also open this panel debate with a brief introduction to the topic. So I will give you the word, please.
Thank you.
John.
Thank you. I have this here, I guess. Would I stand here? Where's the best place to? Well, thank you very much. I'm very happy to be here at this conference and also at this panel on a topic that I feel is quite important. And I was asked to give just a brief introduction to it. And the panel is Arctic Monitoring, Understanding Current and Future Challenges Through Examining the Past. And when it comes to especially environmental issues, these are the typical questions we are asked as environmentalists and ecologists. We're asked, what were pre-disturbance conditions? We want to know what the conditions were like before we have a perceived environmental problem. I think a good example that I use in Canada and would also be a very good example in Norway and Scandinavian countries is acid rain. This was an issue that when I was in my 20s, I was a major topic in my research program. And one of the biggest questions we had was, have lakes acidified? Of course, scientists were saying for very clear reasons lakes had acidified because there was good scientific evidence. But many industries and some countries that were actually producing the acid rain were very strongly opposed to this idea, saying that the lakes were naturally acid. How can you show the lakes acidified if you don't have the acidity levels from the 1800s or 1700s? So no one was measuring pH in the 1800s. In fact, Sorensen only invented pH in Copenhagen in 1909, so there was no way they could have measured pH back in the 18 or 1700s. We need to know background conditions if we think the problem exists. We want to know what is the range of natural variability. I think climate change is a good example of that, perhaps. That we can show all sorts of data. The climate has done very, very odd, very strange things, let's say, in the last few decades. But the argument has still been made, oh yeah, but that's just part of some natural cycle and so forth. Yes, there's natural reasons for climate and environmental change, but we can show that that's not part of any natural cycle. This is something that we're entering into a new world. Have conditions changed? How much? How fast? When? Why? Each of these questions has a time or a temporal component associated with it, and that's one of the biggest challenges we have in environmental and ecological work. I did this analysis back, I was going to say very recently, but when you get older, time goes faster. I guess I published in 2019, so it's pretty close. If you work on paleoecology, 7-8 years, not very long time. But anyways, we looked in the International Journal Environmental Monitoring and Assessment, and looked at the aquatic papers in this major international aquatic journal. We asked how long were most of those programs? Well, as you can see, about 2/3 were 1 year or less in duration. Over 90% were less than 3 years in duration. That's not to say 3 years or less data is not enough to get very reasonable, defendable results. And of course, 3 years makes sense. That's a typical grant. Maybe you have, it's a typical amount of time we expect a doctoral student to spend in the field, for example. But 3 years or less isn't going to be enough time to answer those questions I posed in that first slide. So we really have a challenge with timescales. So we have to push the record back in time. Of course, monitoring is the gold standard. If we have direct monitoring, great. But often we don't, especially in the Arctic, where many places have very, very little direct monitoring. So what do? Well, we use as what we can. And one is, I would say, historical records. This could be Western-type records, colonial records, if you like. To use a Canadian example, the Hudson's Bay Company. The Hudson's Bay, they sent proctors over mainly from Scotland and the Hebrides to go and trade with indigenous peoples, mainly for furs. They didn't write down what the temperature was, but they were sending letters back to Europe. They were writing in their diaries. There's a lot of climate information in those diaries, like the river froze today, or I could not write yesterday because my ink froze. You know, it was pretty cold. So you can get some information. And of course, what we're talking about a lot here, and we work very closely now with indigenous peoples. It may not be written down, but there's a tremendous amount of information that indigenous people hold, especially in their elders and in their oral traditions that we can use. There's modeling. I know there's modelers at this conference. That's another way people try and predict the future, but also hindcast the past. My field is natural archives, and that's all around us. The environment is monitoring for us. We just have to learn how to tease it apart. The trees out there in the tree rings, they're monitoring the environment. The ocean out there in the sediments, it's monitoring the environment. My specialty is lake sediments, and we can actually do quite a lot. It's like a history book. 24 hours a day, 365 days of the year, sediments are accumulating, and in that is an incredible amount of information. We can date those sediments. We can say this is 1950s, this is 1850s, and we can reconstruct the environmental information we never collected directly. Reason why we have real problems with monitoring, it's not what some people refer to as sexy science. I always like this paper in Nature from 2007. Monitoring is science's Cinderella, unloved and poorly paid. And it's true. You know, if you did monitoring, I could not get a grant. I would never be able to get a grant to monitor the Arctic. Even how generous the Canadian Council may be, they would see that's not what you're supposed to be doing in university. That's not direct hypothesis. You know, we have a lot of reasons. I ended up doing 40 years of monitoring, but I called it guerrilla science. I did what I said in the grant proposal, but we also monitored a whole bunch of sites. And now people are pretty happy we did those 40 sites, because that's where we showed a lot of the changes with climate. But we do have a challenge. People don't want to fund it. People don't see it as exciting. And yet many of the key answers lay in monitoring data. And I use my own example here, a very personal example. We published this paper. I was a young man in my 30s at this time. We're talking about 1994 with Marianne Douglas and Wes Blake. And people remember this science paper. It made headlines. It was an early paper on climate change showing we can show with these data that we were gathering in the paleo record, we're showing already signs of significant climate change happening within already the 20th century. People remember that paper. They don't remember the 11 years of what we did. We didn't just take sediment cores and say, we had to know what all those indicators meant. There was 11 years of work of collecting. There's a young, probably thinner John Small. That's not a cigarette. That's a marking pen in my mouth. By the way, it looks like I have a big cigarette, but no. But it's measuring where the algae grow, connecting them to ice. There was 11 years of this before the science paper. No one seems to remember these papers, but we couldn't have done the science paper without that 11 years of information. And I mean, I talk a lot about this. That I get no royalties for this. It's a not-for-profit book, but I talk about this now working with indigenous people. I have chapters like this, different ways of knowing. We work very closely now with indigenous peoples on many of these projects, and we use our data and what I tried to say if you were at my acceptance speech, we try and braid indigenous knowledge with Western science. Indigenous peoples, especially I think partly in Canada, now have a much stronger voice. And they could have even a stronger voice, I believe, if Western science braids with indigenous knowledge in a meaningful and impactful way. The voice will be even louder, I would say, when that happens. And, you know, Canadian system is somewhat complicated. Of course, most people here are maybe familiar with the Inuit of Canada. There's even there, we have 5 groups. They're all Inuit speaking more or less the same language with dialects. But we also have the First Nations. We have 600... the Indigenous peoples of Canada includes 630 First Nations, quite distinct groups, more than 50 Indigenous languages right there, and also the Métis is the third recognized group. So it is complicated, and different peoples work in different areas, but they all have information we can use, and especially in Canada with the Truth and Reconciliation Commission, which went from 2008 to 2015. Senator Murray Sinclair, an Indigenous man from Manitoba, led it. He actually was chancellor of our university. He just died a year and a half ago, but he was chancellor of Queen's University. It really did change how this really, I believe, accelerated the process. And this was a question asked. This was farther south, not in the Arctic, but it was in Northern Ontario. We were at it's long consultations typically, but this was a question asked by an elder. Can you tell us what our lakes were like when our ancestors signed the Robinson-Huron Treaty of 1850? And yeah, I think we can. And of course, this has important implications for reconciliation, for the whole process. And we can show, yes, well, your ancestors signed treaties saying you have joint use of these resources. I work on lakes, so I'm talking about lakes and fish perhaps here. And no, your lakes are not now the way they were in 1850. The agreement appears to have been somewhat shattered. And of course, there's great interest in blending, again, our information with that. So to come down to it, the past matters, I think is what I believe, and I think maybe you do. We have monitoring. Most people think of monitoring, years, sometimes into decades, but that gets very rare. But we can now most people think of paleoecology down here in the millennia or centuries, but on new approaches, we can really blend. We can go almost annual. There really are very strong approaches now for the recent past where we can do. And of course, traditional knowledge is an integral component of that. If you put those 3 triangles together, you indeed have a much stronger and a louder voice. So I think that's major focus of my program, and I hope something we can discuss here. Thank you.
Thank you so much for your introduction to this theme. And as a geologist, I very much appreciate to see that you also agree that the past matters. And I would like to open here asking the panel about the value of knowledge on the past as a tool to prepare for the future. Marie, what are your reflections on that?
Yeah.
Can you hear me?
Thank you very much. I will make 3 points. The importance of monitoring data and historical records. Together with modeling, I used to be a theoretician, sitting in an armchair, think about what nature should be like. Then I changed and I started working on monitoring data with my theoretical background. So I have an ecological model with theoretical unknown parameter that you can estimate using historical and monitoring data. That puts you in a position of having a model that you can play around. So monitoring data on the abiotic physical environment, climate, and the various biological component is very important, coupled with modeling. That's one point. The second point is the importance of interdisciplinarity. But the fact is, although there's being done a lot of good interdisciplinary work, the fact is that science is very fragmented. We publish in different journals, we read different papers, we go to different conferences. If we go to the same conference, we go to different sessions. So science is defragmented very much. And the knowledge gain is suffering. Second point. The third point is the importance of international collaboration, because each country has different traditions. And coming together, we are stronger together. Unfortunately, international collaboration in this period of geopolitical mess we are in is very difficult. But we as scientists, we should always try to cooperate with whoever of our colleagues that we can have a win-win situation with. Scientific boycotts should never exist. We should cooperate with people irrespective of where they're coming from. The Western people are afraid of China because I think China is spying on us. Of course China is spying on us, just like the Western world is spying on China. And by the way, on each other. So we scientists should ignore that. So with monitoring data coupled with modeling, interdisciplinarity, defragmentizing science, and international collaboration, we are in a good position to learn from the past what might happen in the future. Thank you very much.
Thank you. And Marie, as a geoscientist, what's your reflections on the value of knowledge on the past as a tool to prepare for the future?
Yes, so I completely agree what has been said already. Understanding the past is incredibly important when it comes to preparing for the future, and especially in the region like Arctic, where the changes are happening so fast. By studying historical records like sediment cores or ice cores or even long-term ecological data, we can study how the ecosystems have responded to changes in the past, and we can learn how to use this knowledge to better prepare for our future. And I also want to say that I'm fortunate to be Arctic 6 Fellow, part of a collaborative alliance of Nordic universities that are committed to advancing knowledge and fostering interdisciplinary collaboration for sustainable Arctic. So it is possible definitely to work collaboratively and interdisciplinarily. Of course, it's not always easy to find a common language, but it's incredibly important.
Thank you. And I would also like to hear your views on this, Camilla.
Yes, thank you. And thank you so much for a great introduction. It was really inspiring. Yes, so the value of knowledge from the past. Well, I'm glad you brought up traditional knowledge as one of the valuable knowledge systems that can really enlighten us on the past. And as you illustrated, it's local ecological knowledge, traditional knowledge. It can span several generations, and it often precedes scientific time series. And I have also looked into this in my work on northern fjord ecosystems, and I want to challenge perhaps a little bit. Of course, it's valuable, and I completely agree with all that has been said. But I think that what you said about science being defragmented and how are we actually all? Is it actually possible? I also question whether it's possible to actually make all knowledge systems compatible. There is this great dream of if we just integrate all of the knowledge that's there, we can get this holistic picture, and then we can get to know everything there is to know about how the earth and nature has changed in the past. And perhaps that's possible at some points and in some projects. And also it's very interesting to see that so many monitoring projects are so short-lived. So I think that this points to a real need for building these long-term local monitoring institutions with the capacity to follow up and include scientific time series, but also local knowledge, which is inherently local. We mustn't forget that it's challenging to include a knowledge type that is so characterized by its local context, its historical context, differing points of view. And I'm rather an advocate for the perspectives of two-eyed seeing, for instance, which says that, well, we can work together with science, traditional knowledge and science, indigenous knowledge can work together, but perhaps not always. We cannot perhaps always be compatible and arrive at this point where we can get a holistic picture of what has actually happened in the past.
Very important points. And John, you've already shared your views on the importance of past data to sort of prepare for the future. But John, how can we optimize monitoring efforts and the outcome of them?
Well, that's a very, very big question to some extent. We have trouble from many fronts to optimize monitoring, partly by what I already just said, that it's not seen by most funding agency, for example, as something a university lab should be doing. But then you say, okay, then the government should be doing it, but that's the first thing to be cut when there's a government cuts, and there's often government cuts. And so to optimize it, I think we just have to do a better job of explaining why it's so important. I don't want to keep going back to acid rain, but it's sort of really sort of cut my teeth on some of these issues there. And there was a study done with the U.S. acid rain program, and they said, how much did all the monitoring cost to show acid rain was a problem, and how much money did it save by getting the legislation in time? And it was, I believe, 0.1% of the cost of what it would have been if they didn't do the monitoring. I could use a medical analogy as well. If you have good medical treatment, people say, oh, the cost of medicine. Well, it's like education. Is it a cost or is it investment? Or the cost of the environment? But if you catch a disease early or you prevent a disease, it saves, the fold is probably 100 times or 1,000 times savings financially. It's hard to get those things across, though. People, especially when it comes to environmental issues, respond to crises. They prevent. But that's true of medicine too. There's very little preventative medicine. There's a lot of dealing with the disease afterwards. And maybe that's part of human nature. So these challenges are significant, but I think we just have to do a better job of explaining of what can be done with this. Or whatever monitoring we have, I think also as scientists, we have to do a better job of archiving it. Many of us do monitoring for periods of time. It's sitting in a binder on a hard drive somewhere, and it's not in a public database in any kind. And these data are going to be incredibly. We would love to have, we know there were some scientists working on some lakes in Canada or, on some expeditions, but the records, if they ever existed in any form, are lost or they're sitting in someone's attic. And that's, we have to do a better job of archiving data because.
Yes, Christian, what are your views on it?
Yes, I agree that we have to explain the importance of monitoring data, and we have to show again and again what we could not say without monitoring data. There is a discussion among ecologists that experimental work is the important thing. Charlie Krebs from Canada and myself, we were hating each other because I thought he was wasting his time screwing up nature in experiment, and he thought I was wasting my time. Then we sat down and saw the usefulness and importance of both the experimental work and the monitoring data. So combined, we are in a better position to understand what might happen. And the local knowledge, if you have a model that you believe is going to be useful for helping us understand what might happen in the future, it better be able to actually mimic what happened in the past. And that's where traditional local knowledge comes in. And then it can, there can be a very, very, very fruitful dialogue, interaction between the different parts of science and traditional knowledge. Thanks.
So, Camilla, maybe to follow up on that, whose responsibility is the monitoring, and what role should the international research community play in this?
Well, great questions. Whose responsibility is it? Well, I think it's the responsibility of whoever has the resources to do it, and often, well, at least in the Nordic context, that's the government agencies. And well, just to give an example, there is a lot of good work done in terms of monitoring by the Directorate for Fisheries, the Directorate for the Environment, and also by the environmental institutes connected to those directorates doing sustained effort over a long time to actually create time series that are useful. And I think that it's their responsibility also to take into account what knowledge is actually lacking. And often that's the knowledge about non-commercial species, unknown species, species that are not as interesting in terms of what is seen as a kind of national value. What is seen as valuable, for instance, in the Varange Fjord is not valuable in the Oslo Fjord. So there is, of course, a kind of centralization going on in terms of deciding what kind of data is valuable, what is useful, and to see beyond those kind of blind spots. I think that's the main responsibility of not only government agencies but also researchers to be able to find methods to actually fill those blanks.
I think the various institutions, departments, universities, research institutes, they should be responsible for maintaining, monitoring time series. They are responsible for maintaining labs. They are responsible for maintaining experimental sites, and they should, in addition, be responsible for maintaining long-term monitoring time series. It shouldn't be scientists like us that have to apply for some money and then do this on site. It should be the responsibility of the various institutions. And to some extent that is actually happening. But it should be much more of that.
And Marie, as an early career scientist, also with an international career, what role should the international research community play? What is there in monitoring for a scientist as you?
Well, of course, it is also responsibility of the international community, but then it's hard to pinpoint and who exactly that should be. But of course, monitoring is important, not just to a past and for science itself, but also for it has societal consequences. For example, when it comes to lakes, they are providing a lot of services for people, like drinkable water, supporting fisheries, that it's not just for science itself, it's for us.
It is indeed, and I think that has also been highlighted today. So John, you're also known as a highly acknowledged storyteller, and you reach a very broad audience with your scientific results. So John, what story from your perspective would you say has the potential to make a difference? Can we be better at storytelling to be able to conduct monitoring, or how can we improve on this?
Well, I think academic scientists and government scientists, I'm speaking from a scientist perspective, but I think that's true of other scholars as well. We're very good at talking to each other. We're not so good at talking perhaps to the public at large or to the users of the science and politicians. And so some of the blame is definitely on us for a lack of appropriate communication skills. We have probably a pretty good communication skill in writing scientific papers, writing books, academic conferences. What we really need to do is to explain more clearly why the science we're doing, which by and large is paid by the public, why it's important, why it should be at least sustained and improved, and giving clear examples of why this science is important, not for the paper in Nature or PNAS or Science, but why it is important for society and to local communities. And most people think locally, and that's, we haven't done a good job at that. And and you have all sorts of excuses why we don't do that as academics. One say, I don't have time. Well, my argument would be, you should make time, because as I said, it's to your own benefit to do this, and of course the public by and large paid for it. Some would say that, what will my peers think if I'm going to talk? When I started, I was thrown into the fire with acid rain work. It's where a lot of my work started. I was thrown as a 20-something-year-old professor right into media, right into television, microscope, because we were showing acid rain was happening. And at the time, there was definitely academic opposition to what I was doing. The universities have changed, but at that time, this is some time ago, you see the gray hair, but at that time, that is not what a professor did. You were sort of, what we say in Canada, blowing your own horn, or, like Small never saw a microphone he didn't like, but I was in a war with industry because they had microphones. They had glossy magazine articles saying acid rain didn't exist like they do in other industries now. You were in a bit of a war, and if there's an information void, if that information vacuum wasn't filled by evidence, it would be filled by vested interest groups. And so this is the same thing we deal with in monitoring. We have to make it clear and why it's important. And there was another excuse that it might get unpleasant. Well, yeah, sometimes you have to throw stones at giants. Yes, it might get unpleasant, but especially in an academic setting with the protection of academia, if you don't feel that you can go and argue with an industry or a politician with all the protections we have in academia, then there's no hope. So we have a job as academics. We've been given this academic freedom. We have to use it, use it in a positive way.
Yes, Christian.
People like John is very important in explaining to the general public nitty-gritty details of science. And more of us should be involved in explaining how important science, and in fact curiosity science, is for developing society. We are a result of good, solid, curiosity-driven science. And we should realize that no nation can be great without great science. So we should explain to politicians, be it US presidents or whatever, that you can't make a country great without great science. History shows that. One more thing that we scientists should do. We should explain what we know to the politician, but the politician should make the decision, not we. But we can explain to the politician what will be the consequences of choosing A as opposed to B. We are good at that. That's part of our job as a scientist. And we should use that background of us to help politicians and decision makers understand what the consequences will be of choosing option A versus B. Very important.
Marie?
Yeah, maybe I can also add that when it comes to reaching out to broader audience, I think it's also very important to build trust. People need to know that what we do is rigorous, that it's relevant, and that somehow we also need to bring stories with some hope, at least, to know that what people do matters, and that there is some path forward.
And Camilla, from your perspective, what story has the potential to really make a difference?
Yeah, I think this topic is incredibly important, and I don't know if you heard the Arctic Council's new podcast, This Way Up, and they had a very nice episode quite recently about the salmon crisis. And I think this is one example where storytelling is so important, because information, people are always looking for information to explain, for instance, phenomena like why are salmon disappearing from lakes and rivers. And they are looking for information to support, for instance, their belief that it's not overfishing, or that it's not them, or that it's not the aquaculture industry, or that it's not the seal, or that it is the seal, or that it is increasing amounts of sea lice. So it's a matter of actually putting all of that knowledge into perspective, and you're doing that through storytelling. And I think that engaging with people in creating these perspective stories by really going through the work of discussing, it's a lot of work doing that, and perhaps it's not always possible to agree on the same story, but at least what you can do is to take all of that information that people are offering themselves and that they are looking for and that is available out there, and put it into a perspective that can actually perhaps not explain why fish are disappearing, why new species are coming in, why we have all of these climate and biodiversity changes, but at least to provide some examples and stories that can illustrate the complexity of it, and perhaps it's not one single cause. Acidification, sorry, for instance. So little research on that in our regions, and or at least that I know of. Perhaps there is, but perhaps if more scientists were making stories about it, we would become aware of it and start talking about it. So in the podcast episode, This Way Up, it starts with the Finnish Institute of Natural Resources saying that it's something going on in the Barents Sea. It's the ocean. So, and that's something that's people don't really think about when they are looking for information, because it's so little out there. And that's really something that we should all do as scientists, and we have to do it because it's our job to also do pedagogy, to make that information, to produce that information and to make it available.
Next question.
Communication is changing. Mechanism of communication is changing very fast. I like to write newspaper articles. I like to give talks, half an hour talk. But that might not be the most efficient way of communicating. We should listen to the young people. They know ways that works. And have you. I'm involved in a pandemic center at the University of Oslo, and we have involved students to do the communication. They use things I don't understand what they do, but it works. People are reading and listening, podcasts or whatever, much more than they are reading my newspaper articles.
I think we can definitely improve our science communication, also speaking as a dad to a teenage boy. And speaking about communication, so we hear a lot about the consequences, the negative consequences of the ongoing climate and environmental change. But are there also opportunities? And if there are, what are these opportunities, and what could they be, and how can we use them in the future? And should we also monitor them? Maybe we can go back to you again, Camilla, and hear your views on this.
Yeah. No, this is an interesting issue because it's so often, the story is that climate change is negative. But, well, at least for the Sami, the coastal Sami, the cod, for instance, the cod stocks are probably moving more and more northwards. It's positive for the coastal Sami communities in Finnmark. We have new species coming in, like king crab and pink salmon. It has a tendency to boost participation in small-scale fisheries, which increases the strength of local communities to utilize resources, to have a local economy. So it could be positive in that sense. Now the cod quotas are going down again, which it's also it's so unpredictable. Is it going to continue to go down? Is it going up? But at least we know that some changes can be positive from climate change as well and create opportunities. Yes.
It's Christian.
What is the effect of a warmer world? That depends on where you are. And for sure it depends on which species. But let's now talk about cod. I happen to know something about cod. What is the effect of a warmer water for cod? That depends on where you are. If you're in the southern range, it has a negative effect. If it's in a northern part of the range, it has a positive effect because it's moving toward an optimal temperature. But what is south and what is north depends on whether you are on the east part of the Atlantic or the western part of that. So I'm back to the local. That's where it's happening. So this is a non-answerable question. What is the effect of global warming? It depends on where you are. And also, I've been working on plague. And what will there be more? I mean, the black death bacteria. Will there be more plague in the future? Again, it depends on where you are. In northern China, there will be more plague, whereas in southern China, there will be less plague, which is consistent with what is being observed. So it all depends on where you are, and of course, what species and system you're with.
John.
Maybe just add, we're talking perhaps of fish, and there are always going to be winners and losers with climate warming. There tend to be more losers, I think. So the fish is a very good example. Even in the Canadian Arctic, the high Arctic islands, typically there was Arctic char, and there was a small sculpin. Those were the fish, freshwater fish of the Arctic islands. With warming, sockeye salmon are going now into some of these Arctic islands, like Victoria Island, to the point that the Canadian Department of Fisheries and Oceans has developed a cookbook for salmon in Inuktitut because it is a new food resource. So one would say a positive. Negative, that salmon is displacing the Arctic char, which is the indigenous fish. So it becomes hard to judge. Is it a gain or is it an even now? Same thing as one could argue vegetation or greening of the Arctic. Vegetation, especially in the lower Arctic, is moving north with the warmer. That has the potential for increasing possibilities of agriculture instead of just importing all your food. Of course, it's also bringing in exotic species, non-indigenous species of plants and other organisms. So it's very hard to decide if it's, sometimes it feels like short-term winner, but the more we delve into it, they could also be long-term losers. So we have to be very careful. But yeah, with climate warming, there's winners and losers. And That's again where monitoring and the historical record's important, because there were some warm periods and we could see what happened in the past.
Marie.
Yeah, and maybe I can add that we've learned from the past records that ecosystems can adapt to change. But of course, the natural climate changes were taking centuries or millennia.
Years,
So the ecosystems had time to adapt. Now the human-driven climate change is so fast that it's really hard for the ecosystems to keep up.
The new species are coming in. They're out in areas that didn't exist before. They can outcompete local species. But I do more than that. They screw up the ecological dynamics and make the ecological dynamic unstable. And again, this is adaptation, which takes a long time. So it's screwing up the dynamics, and more species might go extinct simply because of that. Thinking ecological dynamics is very important.
Yeah, very good points. And Marie, you study the past, and you more specifically study past greenhouse gas fluxes using sedimentary archives from Arctic lakes, so basically mud from the floor of lakes in the Arctic. What have you learned from that? What are the potential consequences for our future in terms of greenhouse gas cycling?
So we know that methane production is highly influenced by the deposition of organic carbon. Most of the methane from the lake sediments is produced within the top, let's say, 10 centimeters of the sediment. So it is directly influenced by the lake productivity. And with Arctic greening, and Arctic is getting wetter and warmer, there's more primary production in the lakes. So more organic carbon is being deposited into the sediments, and that directly influences the methane release from the lakes. Another finding that we've learned, and that's something that I've been working on quite recently, is that the methane that is being released from those sediments is a mixture of methane that was produced from quite recent organic carbon, so let's say the last 200 years, but there is a fraction that was produced from long stored carbon that has been sitting in the sediment since the retreat of glaciers. And this old carbon is also being mobilized. And so we really need to make sure that we account for this old carbon in the methane budgets.
Really important points, yeah.
Yeah, bad news.
And this is an example of the knowledge that we have gained during specifically during the last few decades from the Arctic. What are, from your perspective, the most urgent steps to take for the Arctic research community? You're welcome, Marie.
Yeah, so I think that we can see that in the past few years, the global attention for climate change has taken a bit of a backseat. The pressing geopolitical situation has shifted the focus away from what is still one of the most urgent challenges of our time. So I think it is extremely important to stay focused on climate change and to keep explaining how important it is, and that it's not just a local thing happening in the Arctic or Antarctic, but it's a global issue. And it is critical to expand and intensify the monitoring programs, because that's where we get the information. And as you said, the longer records we have, the more important the data are. And of course, the collaboration is a key. So if we can share the data, share the expertise, then we can also reduce the costs of the research.
Camilla, what do you think are the next urgent steps for the Arctic research community?
Well, I would like to say collaboration, but having been part of large Arctic projects where there are multiple of actors working together, I wonder, is it moving us forward? How far have we come? So I think that's what we started with was one of the key words I think that John actually mentioned was, or was it Nils Christian? I don't remember, but trust. I also think that transformative change is a key word, that we should always try to foster research that makes it different, that leads to transformative change. And I think that's something, I agree with you, it has kind of taken a back seat. So it's as if people have forgotten the urgency of climate change, and as if, you know, climate change doesn't really, but does it pertain to our area? Is our lakes actually, you know, is this actually happening in our lake or our river? So I think that's very important. So I think I will just stop there. Perhaps a bit pessimistic, but at least to gain some trust in science, I think that's important.
I think people's attitude toward climate change demonstrate that we have not, the scientific community, have not succeeded in communicating the urgency. In 1972, in the conference in Stockholm, we had really all information we needed for making the conclusion that we better change our behavior. Nothing happened. I'm sure you talked, and after that, no one. Well, some people listened to you, but not very many. Not the decision makers. Now, they suddenly have realized that, oh my God, we have to act now. They should have acted in 1972. That shows the that we have failed the scientific community in communicating the urgency of the changes that is going on. And the implication of that is that we have to do a better job, because it is urgent. Human society will not go extinct, but it will be a very different world we are living in. And we see that on the news, not every day, but every year, every season.
And John, how does this? How's your view from the other side of the Atlantic?
Yeah.
What urgent steps do we need to take for as a community, as a research community?
I agree with what's just being said. Like, climate change is the most important. Oh, good. It's still good shit. Climate change is still by far the most significant threat facing humanity, and it's not, that message does not resonate with the general public. And somewhat you understand that. I mean, they're worried about their mortgage, they're worried about their children going to university, they're worried about very local, very immediate things. And you talk about climate and it sounds still very far away, and it's largely incremental. Now, there are episodic things happening where people are paying attention, hurricanes and stuff like that. But it's largely incremental, and it seems like, well, they'll just sort it out and it doesn't affect me right away. I mean, I always use I always find, I'm also, interested in history of science and why decisions are made. And I was having this discussion at dinner the other night, but if we go back, there are a few success stories in environmental science. Acid rain, partial success story. Another one I would say is UV radiation and CFCs. Now, that was a success story. It was the Montreal Protocol, my hometown. In 1988, I believe, the Montreal Protocol. Every United Nations country signed on to the Montreal Protocol. Very quickly, despite all the opposition from industries, CFCs were removed by and large, and industry made even more money. They found cheaper ways to replace the CFCs. And slowly, very slowly, the ozone depletion is being fixed. It's quite stunning that that decision was reached so quickly, with the realization of the problem just a few years previous, and yet you got everyone turned onto that. So why was that? And that was because of a few graphs showing, in my view, it was, I shouldn't say, I wasn't at the Montreal Protocol, but they didn't have any interest in what I had to say. But they showed graphs of the skin cancer rates, and especially in more southern regions, Australia, New Zealand. There were ministers of health at the Montreal Protocol and finance ministers, and they were horrified with these graphs. they were saying not only is this going to completely bankrupt our healthcare system, but it's also going to bankrupt our countries. All these people will now be in hospitals and they won't be producing and stuff. Even though the data, I would say, for CFCs and ozone depletion was there, but it's nothing as strong as we have with climate change. And yet that got legislation like in a blink of an eye when you think of how environmental legislation happens, and solve the problem. We seem to have not be able to do that with climate change because I think most people see it won't affect me that much directly. They see pictures of polar bears and hurricanes, in the Caribbean. Well, I don't live in the Caribbean and I've never seen a polar bear, but we have trouble getting it across that this is affecting you. Never mind they seem to love their children and grandchildren. It seems that's the people. Most of the people in this room are going to make it. But I mean, if you like your grandchildren and children, you might want to start thinking much more seriously about this. But we have trouble getting that across because it still seems far away. People see the temperature fluctuate day to day, and it'll be this 1 degree warmer in 10 years. In Canada, most people say, good, it's cold here, but we just can't get that information across of how serious and I called climate change a threat. Back 15, 16 years ago, I wrote a paper, I called it the threat multiplier. I work on lakes and different types of pollution. Everything I work on is worse in a warming climate. Everything, algal blooms, fish die-offs. We make the whole list. I go through the list, they're all worse with a warming climate, and yet we can't get that across,
Yeah, it's frustrating in many ways.
Yeah.
It is, and maybe we have many opportunities, as we have also heard today, and we are aware of one upcoming opportunity for Arctic research, namely the International Polar Year, coming up. In 2032 to 33. It's sounds far out in the future, but it isn't that far out in the future. So what should we use that for? What would you say is a success criteria, and what should be the priority for the Arctic research community? What should we use the International Polar Year for? This could, in theory, also involve the other pole, but let's focus on the Arctic here. Yeah.
I think the international aspect of this is very important. Scientists are telling the same story in different ways in different parts of the world. And it's likely, but I don't know, it's likely that it might have a much bigger impact on decision makers. I would like to mention one thing, that Norway is actually putting in a lot of money on Arctic research and marine Arctic research. 1 billion Norwegian kroner for studying the Arctic Ocean, assuming that the participating institutions are putting on the table an equal amount. And that is a kind of scientific effort that many countries should do.
I very much agree. And if I may hand the word over to you, Marie, you will probably be doing active research during the next International Polar Year. What will you do? What are you planning to do?
Well, I would like to keep studying the Arctic, that's for sure. But I think that the success criteria for the International Polar Year could be, as we mentioned, the intensifying the monitoring programs. That would be definitely a success if we could do that. And also perhaps getting the much needed attention. So if we could focus on outreach and just keep explaining to people why polar regions matter, I think that would be another success. And of course, if we could use the attention to somehow strengthen the international collaborations that we already have, that would be great.
I think we can go to you also, Camilla. What are your views on the International Polar Year?
Yeah, well, if we take a look back at the previous International Polar Year, at least for Sami research, it was a great boost for the capacity of Sami researchers, Sami organizations to focus on a really burning issue, which was the circumpolar reindeer husbandry climate crisis, and it has continued to boost a lot of good research and put a lot of attention to the really pertinent situation of how reindeer husbandry is impacted by climate change. And this time around, perhaps I think that I think we are at a stage where a lot of people are talking about it, and perhaps it's now possible to implement to a greater degree the participation of local communities in monitoring, to actually establish community-based monitoring programs where they are not there today. I mean, there are some good examples around the Arctic, but it's fragmented, it's incoherent. I'm talking about monitoring programs like ELUCA, like in Greenland, some good examples, but are we actually, at the stage where it's possible to, perhaps further that kind of collaboration between the local monitoring efforts and the global monitoring programs?
Next question.
In connection with the polar year, but also very general, we should make sure that ambitious young people are allowed, that means that they get funding, to do the kind of work they want to do. Because you might think slightly different on things than your supervisors do. I learned from John Maynard Smith, evolutionary biologist in Sussex. He was editor of Journal of Theoretical Biology at the time when we were doing some joint work. And he had a secretary that opened his mail and looked at the information, and she came in and said, "John, you better read this paper." It was a paper submitted. And then he read the abstract indicating that John Maynard Smith was wrong on a particular issue. Then John said, "You know, Nils, these young people, very often unknown, keep telling that I'm wrong on this or that. But every once in a while, they are right, and I'm wrong. And I better be the first one to realize that." So from that I in a way hate young people because they challenge me, but I love them because they make me think. They make me reconsider my ideas. So that's why I think we should make all effort to make ambitious young people do the kind of work they want to do. I'm supporting you for our postdoc.
Thank you for saying that. I will not comment on this because my supervisor is sitting in the room, but thank you for saying it.
Okay.
He loves young people also.
Yeah, so we all want to do more polar research, use the International Polar Year, and do as much Arctic research as we can possibly do, including funding for early career scientists. I totally agree on that. Another strategy or another leg that we have not so far discussed, it's adaptation or mitigation. What do you have any examples as scientists of some successful adaptation strategies to changes in the past in the Arctic that we can possibly explore further in the future? John.
Yes, well, there's climate has changed in the past, and it's never changed this fast. So it's not it's not an easy comparison in some ways. Adaptation, especially a social adaptation, let's say personal adaptation, can be done incrementally, much more easily than almost threshold-like. And ecology does have thresholds. We think of climate change as incremental, but we're hitting what we call tipping points and thresholds. And that's something we have very poor control over. And it's very hard to adapt to a tipping point because it happens so quickly. That's also true for people as well as organisms. Now there are successful adaptations. Well, maybe one of them that I just mentioned, the sockeye salmon going into the Arctic islands now. it's an opportunity, but also potentially a challenge, given that it might be displacing. Well, we know it's sort of displacing to some extent the native species that are there. Is that an opportunity, or is just a compensation, and hopefully comes out at least even? But what worries me, again, we keep thinking of climate as sort of a smooth change. And if history teaches me anything, or ecological history that I deal with, it's when you have these dramatic changes. And a lot of things in lakes, I work on lakes, so a lot of things in lakes they're not incremental. They're yes, no. A lake has a permanent ice cover. The lake does not have a permanent ice cover. It's a yes, it's binary. We have what's called thermal stratification in lakes. It completely changes the ecology of the lake. A lake has thermal stratification, or it doesn't have thermal stratification. Or a lake was too cold to have aquatic plants, and now it has aquatic plants, for example. Those are very different types of lakes. Lakes that I work on in the Arctic, they have changed. We're just about to publish a paper on Great Slave. We did Great Slave on Great Bear, and what we call the Arctic Great Lakes. Great Slave Lake holds the largest indigenous fishery in the world. I don't think not just in Canada. Well, it's certainly in Arctic Canada. That lake has changed fundamentally after thousands of years. We can show since the 1990s, it has completely changed into a different type of lake. We just submitted the paper last week on Great Bear Lake, another of the Great Lakes. We did the same thing on Lake Hazen from Ellesmere Island, the three great, what we call the Canadian Arctic Great Lakes. They have changed completely and fundamentally due to climate change and ice cover since the 1990s. I mean, that's in the time frame of almost everyone in this room. And we don't know what the long-term consequences are. There's been fundamental changes in the algae, which is what we work mainly on, fossil algae, and we can see how the base of the food chain, it's completely different. And we know enough to say that, yes, the amount of algal production, the amount of carbon produced is higher because the summer, people say the winter is shorter. I say the summer is longer because I'm a lake biologist. It's the summer that often drives with you. The summer is longer. There's more algal production. There's more primary production. Good. Like there'll be more fish, potentially more fish. But the type of fish is changing, and the quality of fish is changing in ways that, based on our preliminary data and the data of others, is not in a good direction. So you may have more fish, but not the fish you want. And the fish you want may have much lower, in this case, omega-3s and all those healthful lipids that are so important to, especially in indigenous diet, if that's a major source of your thing. And of course, a lot of things depend on the fish. And this all starts with ice cover driving the algae driving the invertebrates. Invertebrates is what the fish eat. People eat the fish, or other organisms eat the fish. So it's adapting, if you like, but often and people will adapt to it, and maybe new fish species. But there's hidden problems here that we tend to be overly optimistic. If there's anything coming from an old man like myself now, if there's anything I've learned, we're overly optimistic on the environmental consequences of what we do. And we do not appreciate the consequences of multiple stressors, of things happening simultaneously. And, we still do that. We talk about climate change, but, it's not just climate change. It's biodiversity loss. It's everything happening at once. And the combined effects are often much worse than they are in individually. So we definitely have I don't want to end this on such a negative note, but the challenges are highly significant. And every day we don't take action, it's going to be harder and harder to fix this. And we're running out of options. There's still time to do some things, but it's very, very late.
It is, and these are changes I'm also very familiar with when I go back for fieldwork to the same spots in the Arctic. I mainly work in Svalbard and have the pleasure to go back, and these are changes that you can observe just with your naked eyes. And Nils Christian, you
multiple stressors. You have been doing a lot of work on that. And that's important to see the interaction between various stressors. They might not be additive, that could be multiplicative.
It could be even they could be antagonistic.
But there is one that we have not discussed today, and this is harvesting. And the interaction between harvesting and climate change and these abiotic stressors are very important to understand. And I was involved in a study in the Baltic where fishing pressure was having a very profound effect on the fish community. Then we modeled that with time series data, and we asked the question now, if we go reduce the fishing pressure, will we come back to where it was in the past? The answer is no, because the whole environment has changed. To understand that is very important. And to understand, or what characterizes the period before the tipping point is very important. I don't have an answer to that, but it might be worthwhile to compare many of these abrupt changes. Is there any common denominator? That could help us prevent tipping points or abrupt changes.
Absolutely, and it's another highlight of how geoscientists or paleoecologists can help us understand what's going on right now and what might happen in the near future. But going back to the discussion about mitigation or adaptation strategies that could potentially be explored better in the future, what are your views on this, Camilla?
Yeah, so I think that this question is interesting because it kind of covers up or it focuses on success and what does success mean. And sometimes, we are looking for, like these really kind of market adaptation strategies, and then my only examples that came to mind were the unsuccessful ones. Over-harvesting of resources, people over-exploiting something, and then, it's good for a while, but then the economy crashes and the stocks are gone, and then you have a crisis. So I think that the most successful adaptation strategy is the one which has always worked, and that is actually encapsulated in the Sami concept of Birgiopmi, which is the modest harvesting of a mix of resources over time, not overutilizing one resource, such as in the case of commercial fisheries or commercial reindeer husbandry, but the flexible and adaptive combination of a multitude of resources, which is part of a mixed economy, and also and which has proven as the strategy that works best over time.
Very important points, and I think I would like us to take us a little bit back to where we started, to the environmental monitoring and maybe even more so studies of environmental change in Arctic aquatic ecosystems and Arctic ecosystems in general. So how would you say we should encourage students and young researchers to continue to do these studies in the Arctic and maybe even do monitoring on this, whether it's on the sideline or if it's as part of more organized research? What can we do to encourage them? I see we're probably not going to recruit any students in the room here, but what should we do in broader audiences to recruit the next generation?
If you're asking
Yeah.
me first, in my experience, there's no problem in having students interested in Arctic environmental ecological research. They're very, very interested. Usually the barrier is finances. Arctic research is not cheap. Way back, Frank Rigler in the first polar area here estimated each datum point. He was a limnologist like me. Each datum point costs 10 times more in an Arctic environment than in a temperate environment. And I would say that's probably even expanded more the farther north you go. So I think that one of the barriers is, do the people have funding to support graduate students? I don't think there's a problem with interest, at least not in my experience. The question is the logistics. Is the logistics there? Is it possible to do it? Logistics in the form of many places aircraft or helicopter support. If you're doing, depending on what your project is, especially in the Canadian Arctic, it's not you don't drive. Especially the Arctic islands. It's you have yeah, about 50 communities, but many are tiny, 100 people, 200 people, and there's very little infrastructure. A gravel runway for a twin otter or a small plane can land. And for most places to get to the Arctic, you're landing with little twin otters and helicopters are extremely expensive because you have to bring the fuel, you have to take out the fuel. So I would say it's not interest is a problem to encourage. It's actually it's a problem for us to make the opportunities with funding, logistics, and so forth. At least that's been my experience.
It's Christian, what's your experience?
The established scientific community, we should provide means for young people to work in the Arctic. And the Nansen legacy, Marit is sitting here, she was sharing that, is an example. Quite a bit of money was provided by the government and was matched with a participating institution. And much of the money, correct me if I'm wrong, much of the money went to fund young people, PhDs and postdocs, to train the future generation. It is expensive. Ship time and the like, that had to be paid, but lots of money was used. That is an example for having the ambition. I'm using the word ambitious all the time because we should make sure that we have ambitious people wanting to pursue their idea. And that's exactly what happened in Nansen Legacy. There should be more of that. And politicians realize that changes are very, very profound in the Arctic. And then we should explain to them that you better do something about that and provide opportunity for making ambitious young people do things they want to do.
And in my experience, we have one of these sitting here on the stage. And Marie, maybe you can comment a bit on what's needed for you to basically stay in business.
Yeah, well, perhaps I can add to what has been said, that it is also our responsibility to create supportive community that is welcoming, that is strong. And I think that good mentorship is also a key thing for young scientists. And unfortunately, not many universities have clear, so to say, regulations on what the mentorship is and how it should look like. So I think that is also a responsibility to build strong community that is welcoming for everyone and very supportive.
And welcoming new ideas.
Yes.
Camilla, what have you views on this? How can we encourage the future researchers to do such research as environmental monitoring and environmental research in the Arctic?
Yeah, no, this has been a particular focus actually of the project that I'm part of now. It's called Sharing Our Knowledge, and it's an international collaboration funded by the New Frontiers in Research Fund between Canada, Norway, and also UK, and on climate risks to watersheds. And what we realized is really that the current scientific debates and the discussions about what's happening to the watersheds have been dominated by people that are not perhaps appealing to young researchers and students, so they shy off from the topic and they don't want to work with it. So I think it's really important that we get in these young voices that can come with different perspectives and can talk about what they are concerned about. So we are actually funding what we call these young salmon ambassadors. We are sending them to international gatherings. Sometimes it's easier to get young people to participate in international gatherings than in local meetings in Tanabru or Utsjok for some reason. But okay, that's what they want to do. And then in the next time around, they will come and present their views at the local meeting, where they also will meet their own elders and the scientists who actually place a real value in coming to the local communities to communicate about their research, and that's how they communicate. So I think that's very important, and also we have now collaborating with local organizations to do podcasts with young people, just to bring in some different voices and to encourage young people actually to take education and to include also traditional knowledge, indigenous perspectives in their perspectives when they are taking their education wherever, whether it's the University of Life Sciences or it's a UIT or an Oslo or Bergen. At least they should know that it's important for their local community to include those perspectives and that their perspectives are valued.
It's Christian.
We are facing a big problem. The scientific community and the whole humanity is facing a huge problem in the sense that public and politicians are losing trust in science. And they are losing trust in scientists. So we have to work on that. I don't know how to change the situation, but I do know that internet and social media is part of the problem. There is so much crap out on internet that lay people have, I for that matter, have no way of separating the nonsense from the good information. Only in a very, very, very few scientific issues I can, but in general I cannot. So what do? I go to the respected scientific media and communication journals. Not everything there is good either, but it's better. So we have to realize that social media and internet is a problem. So we have, and that's going back to what I said a little bit earlier, we have to use social media and internet for communicating in ways that people want to read. That can help to some extent. Internet is fantastic. I can do a paper together with people in US and China and Japan and Norway, and we communicate the same day. That's fantastic. But it's also a threat to science. It's a huge threat, and we better realize that.
So to continue, just to distill, we need. We have seen here during this panel debate, we need more funding. There's agreement about that. I think we need ambitious early career researchers to stay in business and to be recruited to business and explore the Arctic. And we need everyone to basically trust science. We have a few minutes left, and this is also a session to honor you, John, and the Mohn Prize. And this little window of a few minutes, I think I will actually open up to the audience to get an opportunity to actually interact with the Mohn Laureate of 2026. And just a few moments before I do so, I would also like to point out that we are hosting the Mohn Prize seminar at UIT, the Arctic University of Norway, at 1 p.m. Tomorrow. And it's open to everyone, and you're all welcome to join it. But if there's any questions from the audience, they are very welcome. And this is mainly an opportunity to John. Yes.
You mentioned your efforts that in trying to understand the past, you have to get your hands on as many data as you can get from different sources. Can you maybe comment on the challenges that arise from this? Because I guess it's quite tackling to harmonize these data sets, these different data sources concerning spatial resolution, accuracy, consistency.
Yeah, no, it's a very good point. There is data out there in different formats, but is it in a format that is usable in a scientific manner to make a comparison? And often it's not that direct, but I think Håkansson, a Scandinavian, put it best: if I'm going to battle, I'd rather have a blunt battle axe than no weapon at all. And so sometimes, even though may not be in the same scientific format that I would prefer, it tells us something. And sometimes it's general. I mean, I'll give another acid rain example. We worked on lakes where, using our paleo data, we said the fish was lost using, say, in the early 1900s. And of course, some people who didn't believe in acid rain said, no, that lake never had fish. And then we go and we find there was a fishing club that used to go there, and they kept who got the biggest fish from that lake. So, I mean, that's not a scientific data, but it was pretty useful to say, well, this seems to match. And people not too long ago would dispel indigenous knowledge as hearsay, or and that's at least in Canada. That is, well, in Canada it's legislated that if there is indigenous knowledge, it has to be included. In environmental. I mean, it can be assessed like everything else, but it has to be included. We'll take that indigenous knowledge will not be in the same format as my Excel spreadsheet, let's say, but it definitely. And we co-develop the questions now. We really have changed how we do things. I'm talking at UIT tomorrow, where it's almost like an evolution. We used to use indigenous knowledge as, I'd say, a peer review. We do our study, then we go talk to indigenous peoples and say, this is what we found. Does that make sense? And it worked out very nicely. It was very cooperative, and it was like a peer review, because, and we figure if we can reconstruct what happened in the last 50 years, then more people believe us what happened in the last 10,000 years. And in this case, I'm talking about flooding events. We have now changed, I think we've evolved to that. We have about a year consultation in advance, and we co-develop questions, and we co-develop and work very closely, and using different methodologies, of course, but it's really very much now a co-development, and it's quite different. And yes, sometimes we're not asking exactly the questions. If we were alone, we would have asked, but we're asking the question that's jointly posed, and the sum at the end, I think, is still better than if we were working independently. But yet you're using very different types of sources. So even going back in time, that's an excellent question. Of course, the error bars get bigger too, depending on how far back you go. But when you have no information, any information is better, as long as it appears to be credible. And things like my grandfather used to go fishing there. I take that as credible information, because there's no reason why that would be wrong, really. I mean, so. But yeah, it's not a fish census with gildettes, but it's something. So we use whatever we can, as long as it's believed to be credible.
I think we have room for a final question or comment from the audience, if there's a wish for that. Please.
One question, me as a young researcher, I very much...
Could we have the mic?
Oh, maybe we get a mic.
Hi, my name is Lisa Mattis. I'm from Canada too, Fisheries and Oceans.
Oh, hello.
Hi. For me as a young researcher, I very much benefit from mentorship about how to do research, how to build connections with my peers, but also with communities. How do you see your role, or what you maybe be able to contribute in a broader context of not just to your graduate student, but to the wider young scientist community of how to do research, right?
Yeah, I actually wrote a paper on it. It's called Advice to Early Career Researchers. If you contact me, I'll be happy to send you a copy. But I have 13 points. But I think what my general advice is to do what you love, because if you do what you love, you'll do it well. And it won't feel like a job. Like, I've had a 40-year non-job, I guess, is the way I look at my career. But I also think we have to broadly emphasize the soft skills. Often in a university, and I talk to postdocs too, and part of the postdoc, part of the graduate school is to learn what we might call hard skills. Like, how do you do a fish survey? How do you take this? There's a lot of soft skills. How to interact with people, to basically learn how to work with other people. The importance of communicating properly. These are all types of soft skills that you can learn, and you can learn from your supervisors, from your mentors, but you can also learn how not to do it. I certainly had supervisors, and I learned in both directions. What works, and I'm going, I'm not going to do that, and I think we really have to spend more time on doing that, because it's very sad when I've had very good success with my graduates, but I know other labs where these look like really bright, they enter as bright, enthusiastic people, and within the third year of the PhD, they're, I just want to get out of here, and I'm going to do something else. And that's sad, because it's probably got nothing to do with ability or drive. The soft skills somehow didn't mesh. So I think we have to spend more time on that. And, and I think my final piece of advice is research and teaching are fun. I try and laugh out loud with my students every day, but they're usually laughing at me. But anyways, I think we just have to realize we have a privileged position in doing research and teaching, and just grasp that privilege and use it to make evidence-based policy. The real success to me in science, yes, it could be the Nature and the Science paper. Of course, we all like those. But did it make a difference? Did that evidence come into policy in some way? And I think that's really the final crux, and maybe the final crux of what we're trying to do here. Does it actually make a difference in the end? And
remember what is said. Let people do what they love to do, because then they do it good. And it will be good stuff coming out. He said that. It's very important.
And these were the final words of this panel, actually. So it's 3 o'clock, and we will have to finish this. But I would like to very much thank the panelists for coming here and for the debate. I think we should give you an applause.
Thank you. Thank you very much.
Thank you.
Thank you very much. That was so good.
Thank you.
This came out very
Yeah.